in this example, we have a graph of the quadratic function f of x equals 6x minus x squared. Now, because the x squared term is negative, the coefficient of x squared is minus 1, the graph is an inverted U shape. It's an inverted parabola. We're going to look at the values of f of 0, f of 1, as far as f of 6, all the integers from 0 to 6. So here's our function. To get f of 0, we plug in 0, of course. We get 0 minus 0, which is 0. F of 1 is 6 minus 1, which is 5. F of 2 is 12 minus 4, which is 8. And so on. Okay, so we have the y values corresponding to all of these x values. 0, 1, 2, 3, 4, 5, and 6. F of 0 is 0. F of 1 is 5. So this line has a length of 5. F of 2 is 8. F of 3 is 9. F of 4 is 8. F of 5 is 5. And F of 6 is 0. Now we are going to use the trapezoidal rule to estimate the area of the region enclosed between the curve and the x-axis in the given domain. So what region is that? Well, it's very clear, isn't it? It's this region here. Okay, so we're going to get an estimate for this region. That means we're not going to get the exact region. The trapezoidal rule will actually estimate each section of the region by a trapezium or a triangle. Like for the first region, we are going to be, the trapezoidal rule will give us the area of this triangle. For the second region, trapezoidal rule will give us the area of this trapezium by drawing a straight line from this point to this point. Okay, we'll have a trapezium, so there's going to be a little bit left over. In this next region, well, this next region is approximated by this trapezium, and so on. The next region is approximated by this trapezium, and so that's what we're getting. We're getting the area of trapeziums. Well, the first and last of them are actually right-angled triangles. Okay, so there's a formula for doing that. So let's see the formula. Here it is. Now, the h in the formula stands for the width of each strip. So each strip, as you can see, has a width of 1. Okay, so 1 goes in for h. Now y1 is the height of the first strip. So let's look at the first strip. So here's the first strip. It's actually a right angled triangle. The height of it is just the value, the y value at 0, which we know is 0. Okay, f of 0 is 0, so 0 goes in for that. So 0 goes in for y1. Now yn, n stands for the last strip. Okay, it's actually the y value of the last point. That's f of 6. F of 6 happens to be 0. So 0 goes in for that value. Okay, so n, you know, it depends on the problem. In this case, n is like, you know, y1 is 0. It's the height at this point. y2 is the height at this point. y3 is the height at this point. y4, y5, y6, y7 is the height at this point. So n is actually 7 in this example. Okay, but you only have to remember that yn is the y coordinate of the last point that makes up the interval. Next we have to take 2 times the sum of all the heights between the first one, y1, and the last one, yn. So the yn minus 1 stands for the penultimate or second last height. Okay, so the y2 as far as yn minus 1 basically just stands for these heights here. So we're just summing all of them. So 5 plus 8 plus 9 plus 8 plus 5. So we just sum all the ones in between the first and last heights. So we sum them and we multiply by 2. So if you calculate this thing, you'll get the area of all the trapeziums which approximate the area under the curve. That area is 35.